Yay! Hey, hi. Words. I'm making words at you. Welcome everyone. We're at another video today. We are just really in that realm now of thinking about. Wait, wait, wait for it. We're thinking about problem solving. So today we're just going to be talking about like how do we unpack and make sense of like these story problems or word problems that we get. What is the operation that we're doing? How do we set it up and do so? Remember, we have multiple strategies. In this case, for this video, we are going to be thinking more about how it is that we multiply fractions and whole numbers. So we really are just thinking about products that occur, products with fractions. So like the different areas we might see that, whether it's mixed numbers, fractions, so on and so forth. So let's dive in and do that today. Let's just like think about how we can unpack and understand the things that we're going to do. We're going to start today with this first story problem over here. I'm going to go ahead and kind of get this out of the way so we have some workspace. And let's dive in, right? Like first, like let's just read and kind of make sense of what's going on. So in this story or word problem, it's talking about a recipe for cookies. Okay, so we're making some cookies. We need 2 1/4 cups of flour. So I don't know. For me, I always just like kind of put numbers out that I see right away. For every dozen cookies that I make, how much flour will you need if you bake 3 1/2 dozen cookies? Okay, so great. So what we're making sense of this is this is my flour, right? And again, this is me just unpacking and thinking. Um, we also know that we have 3 1/2 dozen. And we also know, based on the question, it says how much flour will you need, that whatever answer I have, it's going to be flour. It's in fact, it's going to be cups. It looks like cups of flour. Cups of flour. So that's another technique you know to think about is like we know our answer is going to go right here. Now we already have our label and we haven't even started. So if we think about this process, like, you know, even if I was to T-chart this out and think about it, well, it's saying to me, right, this would be like the dozen, this would be like the cookies, and this would be the flour. And so like if I had 1 dozen cookies, that would be 2 1/4 cups of flour. If I had 2 dozen cookies, that would be 4 2/4 cups of flour. Right? Because we're doubling, we're adding, whatever. So this is like that concept of repeated addition. Um, but that gets kind of difficult because it's like 2 1/4 3 1/2 times, right? So I guess at least what we do know is we do have an equation of this. We do know that what we're doing is we're going to take 2 1/4 and we are going to multiply it by 3 1/2, right? Because it's going to be really hard to show that repeated addition. So I'm just multiplying in this. So let's see, what do we got? Well, with one technique we can do is we can do the, what I like to call the convert, multiply, convert system, meaning what we'll do, and now I'm gonna have to make some space. So sorry, I'm gonna erase this. I hope that made sense. I always like having all the work on the screen as we see it, but you know, I just want to make sure that we're making sense of what we're doing and we can see. Okay, so convert. So what that means, convert, the first thing we're going to do is we're actually going to turn these into top-heavy fractions. So as I've always said, if that's a process you are unaware of, feel free to watch the videos to make sense of that. But what I know is I have 4 pieces and 2 holes. So 4 pieces times 2 holes is 8 pieces, plus this 1 piece here is 9. So that gets me 9/4. And that's all I've done. This is equivalent. 9/4 is equivalent to 2 1/4, right? I'm just converting it again to top heavy. And I'm going to multiply that by, let's see, 2 pieces by 3 holes. So that's 6 pieces plus 1 minus 7/2. So now that I've done that, I actually just get to multiply my fractions. And again, that's step 2 here. If I multiply my numerators, so 9 times 7 is 63. And then I multiply my denominators. So 4 times 2 is 8. That gets me 63/8 cups of flour, which doesn't really make sense because, again, that's a top heavy. So what I'm going to do is I'm going to convert. This is that third step again. I'm going to convert back to a mixed number. To do so, we know that we have a division problem. We're really looking at 63 being divided into groups of 8. So let's see. I know that 8 times 8 is 64, so that's too much. And that means that 8 times 7 is 56. So let's subtract, that's too big. So that's a 7. So 7 left over. Okay, so what this tells me now is that I have 7 holes with 7/8 left over. So there we go. We just found it. We just found the answer, actually. If I was to make 3.5 dozen cookies, I'm going to need 7 and 7/8 cups of flour. Okay, so hey, not bad. First one, not bad at all. We just unpack it a little bit. We think about what strategy you use. I think in this case, because we had some, I would say some smaller numbers, the convert, multiply, convert technique is good. That's one way of doing it. But of course, there are other ways of solving. So let's look at our second word problem today. It says you have $36 and you spend 3/4 of it on some new clothes for school. How much money do you have left? Okay, so there's some cool things in here right away. Fraction of, right? That word of. If you remember in all the work we've done, that's telling me right away I know I'm multiplying. And what it's telling me is that if I read this out, I have 3/4 of 36. So this is actually like 3/4 groups of 36. This is not that ideas of, and this is where it gets a little confusing, right? Like I can do some multiplication in here and just get an answer. But if I truly was to model and make sense of this, what it's telling me is that I have $36 to begin with. So what I'm going to do is I'm going to model that 36. I'm just going to model out 36 things. And maybe I'll model out little like dollar bills. So let's see, 1, 2, 3, 4. Yeah, it's 36. So I could do like 4 rows or 4 columns of 9, right? Let's see. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, 13, 14, 15, and 16, 17, 18, 19, and 20. I might have to do another row. Oh, maybe I'll go, oh, wait, let's do this because it's not going to fit. I'm going to go the other way. So I'm going to do 4 rows of 9. 1, 2, 3, 4, 5, 6, 7. This is fun. Let's go the other way now. 8, 9. There you go. And then I can do 4 rows of that. That would be 36. So this is what I'm doing. And this is a pretty big model. So, other times maybe this works. Maybe right now this doesn't. My dollar bills are starting to look like loaves of bread. Things are getting kind of weird, but that's okay. So here's a model that literally represents 36 things. Now, what I am trying to make sense of here is that I have taken 3/4 of this. So what I'm doing is I'm actually taking this array, and that's what this is, right? It's an array. It's equal rows and columns, and I'm cutting it into groups of 4. So if you see that, all right, this would be 1 group, 2 groups, 3 groups, and 4 groups. And what I know is that I've literally spent 3/4 of that. So that would be 1/4. Why did I start at 2? That's really funny. There's 1/4 of it. I'll go here, 2/4 of it, and then 3/4 of it. This is the amount I've spent. So now if we look at that, the question is, how much do I have left? It didn't ask how much did I spend. If it asked how much I would have spent, then I would be counting this, but it's not. It's actually asking how much do I have left. So this model is really good because I don't have to do any more math. I can literally just write how much is left over in here. And what's left over is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have $9 left left over. Sweet. That actually worked out really good. I'm actually glad I used that model. I didn't really think of it ahead of time. It was just seemed natural because again, that idea of a fraction of a whole number, typically it is really good to take that whole number if it's not too big and then model it so that you can cut it into these groups of 3/4. So, all right, cool. So far, so good. We're doing pretty good. We've happened to, what did we do in the first one? Oh yeah, we made some cookies. We have now spent some money and have $9 left over. Let's go ahead and dive into the final problem here and just kind of think about this one. And as always, it's always if you'd like pause, right? Pause the video, think about what's going on, solve the problem yourself, and then unpause and see where we're at. So, question 3. The bedroom of my apartment is 14 and 1/2 feet long and 8 3/4 feet wide. What is the area of the bedroom? Okay, cool. So go ahead and give this a pause and see if you can't solve this yourself and then come back and think about what you would do. So welcome back. Always like, when do I pause so that you can pause? But welcome back. Let's just, hopefully you've already done this, but let's unpack this one and think about what we're talking about. So keywords first, as we read that. One is area. So as soon as I hear that area, again, I know I'm working with an array. So I'm going to go ahead and take this array and build it here. And what I know about it is that one side of the bedroom is 8 3/4 feet. And then the other piece, maybe I'll change the color. So this side here is, whoa, is going to be 14 1/2 here. Okay. And I want to know the area. I actually want to know, this is where I'm like, do I do this? Because I'm just going to have to delete it because we need some space. But I want to know how much space that this takes up, right? My rows versus my columns. I have 8 3/4 rows times 14 1/2 columns. Well, that doesn't always pan out very well. So I definitely cannot go with that first technique with like, I'm just gonna, well, I guess I could convert, multiply, convert. But those are some pretty big numbers I'd be working with. I just hesitate. Like I could do it, but we're talking about multiplying some larger numbers. I don't know. I'm gonna try a different technique. This isn't like an of whole number thing, so it's not like I'm gonna show 8 3/4 of something and then cut it into 14 1/2 parts. Like that would be really weird. That would be confusing. That actually doesn't even compute in my own brain. But this is area, so I'm actually literally just gonna use an area model. I'm gonna get rid of these little guys here. Yeah, see you later. Um, and let's do that. Let's think about unpacking this as an area model. Let's think about like this wall here is 14 1/2 feet. Well, one thing that I know is a number that I could really use here is 14. All right, that's 14 holes right there. And then maybe what I'll say is like this represents the 1/2 foot right here, which makes sense. That's expanding it out, right? 14 1/2 would be the same thing as a group of 14 and a group of a half. Um, and so that kind of creates that. And then if I think about this side of the wall here, well then, this would represent like this much right here would represent like 8 feet. And then this, let's do another color here. Let's just go right here, would be the 3/4 of the feet, right? So when you think about that area model, idea of like how you expand something out, that's kind of what we've done. And in this case, I really tried to draw it to scale, so it actually makes sense. And so then we got to put this together. We're just looking at this as a form of multiplication, right? In this case, I have 14 columns times 8 rows. Those are all whole numbers. I don't know that, so I'm actually going to take this one step further, and I'm going to take this 14 and cut it into two compatible numbers, and I'm going to turn it into a 10 and a 4. Because now I actually can say, oh, I know 10 times 8 is 80. And I am going to say that 4 times 8 is 32, and those are my whole numbers. Over here, I'm doing 8 times 1/2, which equals 8 halves, which 8 divided by 2 actually equals 4 wholes. So that's panning out. Again, if these things don't make sense with the multiplication, please watch the other videos in which we are showing this multiplication. Oh, I guess I'll bring this down. We now have 3/4 times 10. So that would be 30 over 4. I'm going to have to convert that. I don't know what that is. We have 3/4 times 4, which actually is 3. Right? 3/4 of 4. If I took 4 and broke it into 4 groups, I'd have one in each group. There's 3 groups, so that just equals 3. So, and again, if you sometimes, I'm thinking about this math in other ways, but if you want to see the math I was doing there, right? 3/4 times 4 gets me 12/4. And then 12 divided by 4 equals 3. So that's how I got that. And then over here, we have 3/4 times 1/2. And that's going to get me 3/8. And then, oh yeah, and we have the 34th. So now I'm going to take all these pieces and I'm going to have to put these together, and I'm going to come down here and erase some of this. I'm going to erase this now. I hope you, again, remember where that came from. But let's put some things together. First, I'm going to convert this 30/40ths into a mixed number. That's 30 divided by 4. So let's see, that's 4 times 7 is 28. 28 minus 30 is 2 fourths. So that's 7 and 2/4. And I'm going to have to add that to 3/8. Okay, that works. We'll just multiply this by 2 and this by 2. So that gets me 7 and 4/8 plus 3/8, which equals 7 and 7/8. So that would be this part and this part have been added together. And now I'm going to add my whole numbers. Boy, this is always like so, there's so much to this, which is great. I feel like I'd use another technique, it would be even more. There'd be more I'd need to be worried about. So 80 plus 32 plus 3 plus 4. So 7, that's 9, and 111. So 100, oh, excuse me, 119, not 111, 110. Anyway, whatever. 119 plus 7 and 7/8 gets me, what's 7 plus 119? 126. So this is going to be 126 and 7/8. So that's how big the bedroom is. It is actually 126 and 7/8 feet. I can't forget my unit of measurement. And there we go. We've done it. We solved all these problems, which is great. Look at how we did this. In fact, each time we really used a different technique, which I really like. That was cool. Same thing. We're multiplying mixed numbers and fractions this whole time, but in problem 1, we did like the convert, multiply, then convert. In problem 2, we did the like draw out the number of things you have and find the fraction of it. That's a big fraction of is a big thing for real, trust me. And then in this case, we used an area model, which I actually love this area model. It looks so clean. I don't know about all the math over here. I mean, it's still clean and good, but I like the way this area model came out. I like I really tried to scale it. I'm actually really proud of myself too, because I took 14 and turned it into 10 and 4. How fun was that? That just made the math work better. Anyway, I will stop there. You are all amazing, wonderful people. Keep up the good work. You did an amazing job watching this video. Remember, if you have questions, ask questions, and we will talk to you next time. Peace.